Welcome back, everyone, to the Deep Dive. You know we love to go deep on the latest in AI, and today is no exception. We're talking about something that could totally change how we train those AI assistants you use every day, the ones powered by those large language models, or LLMs.
Right.
Now, you've probably heard of RLHF, reinforcement learning from human feedback.
Yes.
It's been the way to make AIs sound more human, follow your instructions better, but it has a big problem. It can be really slow.
Yeah. It's a big bottleneck for sure.
So that's where asynchronous RLHF comes in. It's like, imagine a single lane road where everything has to wait for the car in front.
Uh-huh.
Asynchronous RLHF is like building a multi-lane superhighway where everything can move at the same time. The AI can be working on generating text, getting feedback, and updating itself all at once.
It's a lot more efficient.
And get this, it can even learn from what older versions of itself did. Kind of wild, right?
Yeah. That's the off-policy part. We'll
Okay.
get into that.
Definitely want to dig into that. And to help us unpack all of this, we've got some awesome research to dive into today. It's from some real AI heavy hitters, Mila Quebec AI Institute, University of Montreal, the Allen Institute for AI, oh, and Google DeepMind Canada, and the CFAR AI chair.
Wow. That's quite the lineup.
And to guide us through this, well, we've got our amazing AI expert here.
Happy to be here.
So to kick things off, one of the things that really jumped out at me from the research is this. There's this popular LLM library called VelM, and the researchers found it was 12 times faster than standard tools at generating text.
Yeah. That's a pretty significant difference.
Yeah. And it gets even crazier because that speed difference gets bigger as the AI models themselves get larger. And we all know those AI models, they just keep growing.
Absolutely. Larger models, more data. That's the trend for sure.
So that's where asynchronous RLHF steps in to kind of save the day. But I'm curious, what's the secret sauce? How does it actually speed things up so much?
Well, at its core, it's about running two key processes in parallel,
Yeah.
right? We have the text generation process and the training process. Asynchronous RLHF puts each of those on their own separate GPU.
So they're not stepping on each other's toes. They're working side by side.
Exactly. Think of it like different departments in a company. You've got your design team, your manufacturing team, quality control, and they're not waiting for each other to finish before they start. They're all working simultaneously.
Okay, so it's not just about speed. It's about like streamlining the whole workflow.
Yeah, exactly. Working smarter, not harder.
I like it. So did they actually put this to the test? See how it works in the real world?
Oh, yeah, they did. They used asynchronous RLHF for TLDR summarization, getting those nice, concise summaries of longer texts.
Yeah.
And what they found is that it was 25% faster than the traditional RLHF. But here's the key, without any loss in quality.
Oh, so you get the speed boost without sacrificing the accuracy of the summaries.
Yeah, exactly. It's a win-win.
Okay, but here's where my brain starts to hurt a little bit. If it's learning from data made by an older version of the AI, isn't that kind of like learning from outdated information?
That's a great question, and it gets at the heart of what we call off-policyness. Think about how we, as humans, learn from our past experiences, right?
Yeah.
Sometimes those experiences are directly relevant, sometimes not so much. The same thing applies to AI. It can learn from its past, from data generated by a previous version of itself. But the question is, how far back can it go without messing up its learning, its ability to adapt?
So how much of a time traveler can the AI be? Like, how far back in time can it learn from effectively?
Well, what's interesting is they found that the off-policy learning did lead to a slight dip in performance, but it wasn't a huge drop-off. And here's the really fascinating part. The bigger the AI model, the better it seemed to handle this off-policy data.
Wait, so bigger actually is better when it comes to learning from potentially outdated info?
Exactly. It seems counterintuitive, but think of it like this. Larger models have a much wider range of experiences to draw from. So they're better at spotting patterns and applying them, even if the data isn't perfectly up to date. It's like having a mentor who's seen it all. They can still give you good advice, even if they haven't encountered your exact situation before.
Okay, that actually makes a lot of sense. So now we know asynchronous RLHF works. It can learn from the past. It can speed things up. But how do we kick it into overdrive? Like, how do we make it even faster?
Well, the researchers explored two really interesting scenarios. One is where getting feedback is the bottleneck. This often happens when humans are involved in the loop.
Because humans are, slower than computers.
We operate on different timescales, let's say.
Right.
They call this generation bound. So in these cases, the key is to make the most of each batch of generated text by doing multiple training updates on it. It's like really studying the same material over and over again to make sure it sinks in.
Repetition, repetition, repetition. I'm all about that.
Exactly. But there is a potential trade-off here.
Oh.
This intense focus on repetition might lead to what they call drift. The AI's knowledge might start to drift a bit from its original training data. If you only ever study one subject, you might become a super expert in that area, but forget some of the things you learned.
Ah, so it's about finding that balance. So what's the other scenario they looked at?
The other one is when the training itself is the bottleneck.
Okay.
And that's called, very logically, training bound. In this case, the solution is kind of the opposite. Have the AI generate even more text samples than usual, and then just pick the best of the worst ones to use for training.
Ah, so you're just using the cream of the crop and maybe the bottom of the barrel, too.
Exactly. You focus on the information that will give the AI the biggest learning boost. The researchers found this could speed things up by a factor of 2.5. But again, there's that potential trade-off with drift. Focusing too narrowly could lead to a less well-rounded AI.
Always trade-offs. Okay, enough theory. Did they actually try this out on a real-world AI project?
Oh, absolutely. They took an 8 billion parameter Llama model. That's Llama 3.1.
Wow.
Which is already in the realm of really advanced AI assistants.
Yeah.
They trained it on a massive instruction-following data set, and then, get this, they had G2C4 judge its performance.
Whoa, so they brought in the big guns to evaluate it. That's like AI judging AI.
Right.
So how did it do?
The results were really impressive. Asynchronous Rlhf was 38% faster than traditional methods, while maintaining the same level of accuracy. It's like training for a marathon in record time and still winning the race.
That's incredible. I mean, it really feels like asynchronous Rlhf has the potential to just completely change the game when it comes to building the AIs of the future.
I think that's a very fair assessment. It offers some incredible possibilities, especially as we keep moving towards these larger, more complex AI models.
It's definitely something to keep an eye on. This has been an amazing deep dive into the world of asynchronous Rlhf. And, we've seen how it's pushing the boundaries of AI training, making it faster, more efficient, potentially even more powerful. But before we get too carried away with all the amazing possibilities, let's take a step back and consider some of the potential challenges and think about the future directions of this really game-changing technology. We'll be back in just a moment to explore those aspects. Stay with us.
So, as exciting as all this is, it's important to remember that asynchronous Rlhf isn't like a magic bullet. There are still some practical challenges we need to tackle.
Right, there's always a catch. So let's talk about those. What kind of challenges are we talking about?
Well, some of them are pretty technical. Like, there's this thing in Python called the Global Interpreter Lock, or GIL. It can really slow things down.
The GIL, huh? I've heard of that.
Yeah, it basically prevents different parts of the code from running truly simultaneously.
So even though we're trying to make things parallel, there are still limitations within the programming language itself.
Exactly. And then there's the challenge of making sure that those separate processes for generation and for training can talk to each other efficiently, right? Sharing data, sharing model updates, that communication takes time.
So even though things are happening in parallel, there's still some back and forth that can't be avoided.
Right. And those little delays, they add up, especially when you're dealing with huge AI models and tons of data. The researchers actually found that their speed gains weren't as dramatic as they theoretically could be, and they think these technical bottlenecks are partly to blame.
Okay, so it's not all smooth sailing, but are these technical challenges something we can overcome, or are we kind of stuck with them?
I'm optimistic. I think with, clever engineering optimization, we should be able to smooth out those wrinkles and unlock even more speed gains.
So it's like streamlining a complex production process. There's always room for improvement. Okay, so that's the technical side. But as this technology develops, are there any bigger picture questions we should be asking about asynchronous Rlhf?
Absolutely. We need to remember that we're still early on in exploring this technique. More research is needed to really understand all the nuances and potential pitfalls.
Like what?
For example, we need to look at how this off-policiness, that learning from past versions of the model, affects the AI's learning over the long term.
Okay.
Can we keep pushing the limits of how much it learns from its past selves without, messing up its ability to adapt to new information?
So finding that balance between speed and the flexibility of the AI's learning process.
Precisely. And that sweet spot, it might change depending on what the AI is actually being trained to do, right? It's not a one-size-fits-all situation.
As we wrap up this part of our deep dive, what are some key takeaways you want our listeners to walk away with? What makes asynchronous RLHF so important for the future of AI?
I think the most important takeaway is that this has the potential to fundamentally change how we develop AI systems, especially large-scale ones. It offers a way to train AI faster and more efficiently, but without sacrificing performance.
And that's huge, especially since training these massive AI models takes a ton of time and computing power.
It really does. It's like we're finding a shortcut to building the AI of the future. And that has huge implications for, well, everything from, personalized virtual assistants to scientific discovery to solving some of the world's toughest problems.
It's like unlocking a whole new set of possibilities powered by smarter and faster AI. Can you give us some specific examples of how this could impact people's lives?
Well, imagine a world where you have a virtual assistant that truly understands your needs and your preferences, one that learns and adapts to your unique way of interacting with the world. Asynchronous RLHF could be the key to making that a reality.
So it's taking the AI assistants we have today to a whole new level of personalization.
Exactly. It's about creating AI that feels less like a generic tool and more like a partner that understands and anticipates your needs.
That's pretty amazing. What about beyond personal assistants? Are there other areas where this technology could have a big impact?
Definitely. Healthcare is a prime example. Imagine AI-powered tools that can analyze medical images with incredible accuracy, or treatment plans that are custom-tailored to each patient's situation. Asynchronous RLHF could speed up the development of these tools, making them available to more people sooner.
So we're talking about AI that could revolutionize healthcare.
That's the potential we're looking at. It's about empowering doctors with cutting-edge tools and giving patients access to the best possible care.
This is incredible stuff. It feels like we're on the cusp of a major shift in how we develop and interact with AI. But before we get too carried away with all the amazing possibilities, let's take a moment to explore some of the practical considerations and questions that arise as we move into this new frontier. We'll continue our deep dive after a short break. Stay tuned. Welcome back to the deep dive. We've been talking all about asynchronous RLHF and how it could really shake things up in the world of AI training. Before the break, we're getting into some of the really cool things this tech could enable, like super personalized AI assistants and healthcare tools that could totally revolutionize medicine. Seems like AI is everywhere these days.
It's amazing how quickly AI has become a part of our daily lives.
Totally. And with AI advancing so fast, I can't help but wonder, what's next? Where does asynchronous RLHF fit into this big picture of AI shaping our world?
One area where I see huge potential is personalized learning.
Oh, yeah.
Imagine if we had educational software that could adapt in real time to each student's strengths, weaknesses, and learning styles. Asynchronous RLHF could be the key to building these systems much faster and making personalized education a reality for so many more students.
So it's like having a personal AI tutor for every student.
Exactly.
That would be incredible. Are there any other areas where you see asynchronous RLHF making a big splash?
Definitely. Scientific discovery is another exciting area.
Okay.
Think about AI that can sift through mountains of scientific data and help researchers discover new things or connect the dots in ways humans might miss.
Yeah.
Asynchronous RLHF could help us train these AI systems much faster, potentially leading to breakthroughs in medicine, climate change, material science, all kinds of fields.
It's pretty amazing to think that AI could be a key tool for tackling those big global challenges.
It really is.
But with all this talk about AI getting smarter and faster, I gotta admit there's a part of me that's a little, I don't know, uneasy.
I understand. It's natural to feel some hesitation when a technology advances this rapidly.
Right. It's like, are we opening Pandora's box here? You know, with all those sci-fi stories about AI becoming too powerful.
Those concerns are valid, and it's so important to talk openly about the potential risks and benefits of powerful AI. As we develop these systems, we need to think very carefully about how to make sure they're aligned with our values and used for good.
So it's not just about building tools, it's about shaping the future responsibly.
Exactly. And it's a shared responsibility requiring collaboration between, well, everyone. Researchers, developers, policymakers, the public. We need to work together.
That's a good point. Well, we've covered a lot of ground today. From the technical details of asynchronous RLHF to its incredible potential and the ethical questions we need to consider.
It has been a fascinating conversation.
I always enjoy diving deep into these topics with you.
Me too.
And to all our listeners, thank you so much for joining us today. As we move forward into this world where AI is becoming more and more prevalent, It's so important to stay curious, stay informed, and keep asking those big questions.
Couldn't agree more.
That's it for our deep dive into asynchronous RLHF. We'll be back next time to explore more fascinating developments in the world of AI. Until then, keep learning, keep exploring, and keep wondering.